Trigonometric equations of quadratic types. So here's some given information. It's good to read over it. Let's just go solve some. In example 1, we have a question. It says solve the equation on the interval of 0 to 2 pi. So that means we're talking about radians. So make sure your calculator is in radians, and it's always good to know the unit circle. So in order to solve that, we need to have sine, not sine squared, and we need to have it by itself. So what I notice, I have a minus 3/4 here, so I'm going to add 3/4 to both sides. Now that I've done that, I got sine squared x is equal to 3/4. All right, in order to undo that square, it means we need to take the square root of both sides, and square root is even, so we get a plus or minus. So now I got sine x is equal to plus or minus square root of 3 over square root of 4. I just want to clean that up. It's plus or minus square root of 3 halves. Okay. Now that I've done that, I can go to the unit circle and find all values of when sine of x gives me square root 3 halves plus or minus. And when I do that, what do I get? I get these points here. I get pi thirds, I get 2 pi thirds, 4 pi thirds, 5 pi thirds. Oh. Oh. So let's solve for number 2. We're going to solve the equation on the interval of 0 to 2 pi. I noticed that I got sine squared and I got this negative half here. So I'm going to add the half to both sides. So now I got sine squared x is equal to a half. And we're going to undo that square. We're taking the square root of both sides. And since it's an even root, we get a plus or minus. Now I have sine x is equal to plus or minus square root of a half. Well, let's clean this up. Plus or minus square root of 1 is 1. Square root of 2, well, that's 2. That is not written in simplest form. So what I'm going to do is I'm going to multiply by its conjugate, which is the square root of 2. Square root of 2 times square root of 2, if you need to, just rewrite it like this. And then the root divided by the power of 2 gives me just 2, right? So I'm going to multiply top and bottom by it. And let's come back here. I want to rewrite this another way you can write it. You take the radicand, which is inside the root, raise it to the power, divide that power by the root. 2 divides 2 is 1, and that's how I got this. All right, now that I've done that, I have sine of x is equal to plus or minus 1 times square root of 2. Again, square root of 2 times square root of 2 is 2. And now that I know that, I can go to the unit circle and I can find all values for that. And I get pi fourths, 3 pi fourths, 5 pi fourths, 7 pi fourths. All right, so now let's solve for number 3. Number 3 says find all real numbers in the interval of 0 to 2 pi that satisfy the equation. Use the radian measures. I want to talk just a second. I didn't bring this up with a go, interval notation. Sometimes we need a refresher. This bracket here means that we can include 0. We went all the way up to that point of 0. This parenthesis here means that we're going as close to 2 pi as possible. We're just not stopping on it. I mean, we're just getting as close as we can to the 2 pi. All right, so now let's look at this. This is what's given to us. So I'm going to rewrite it in a format that will be easier to solve. I got sine squared and I got sine. So I have a quadratic going on here. So let's let y equals sine x. So when I do that, now I'm going to substitute that y in. I get 7y squared is equal to y. And I can write it where the y values are all on one side by subtracting the y by both sides. And now I get 7y squared minus y is equal to 0. And I have a quadratic. And I also notice that I have a greatest common factor, which is y. So let's factor it out. Now that I did that, I'm going to have 2 values. I'm going to take this one, set it equal to y, or sorry, set it equal to 0, and this one set it equal to 0. And I'm going to solve for this y by adding the 1. And now let's divide by that 7. So I got y is equal to 1/7. All right. So what do I know? When I take the sine x of 0, I'm going to find the inverse. And when I plug in 0 here, I get 0. When I take the x inverse of x equals sine inverse 1/7, we get 0.1. So now we have some values going on. We got 0, 0.1. And you just keep looking and you'll find more values. In this case here, we're going to find 3, 3.1, All right, so let's solve for 4. Find all values of theta in the interval of 0 degrees to 360 degrees. Now we're on degrees. And again, you see the notation, that bracket there. All right. Wow, what do I got going on? Definitely got a quadratic going on. And I see that I have a perfect square. 49 is 7 times 7, right? 25 is 5 times 5. We got a perfect square. That's a square. That's to the power of 1. All right. So let's do this. I can rewrite it as 7 sine theta plus 5 all times 7 sine theta plus 5. And how do I know that we're using plus? The sign on C is what we're working with, right? Or the sign on C, excuse me. The sign here, and if you need a refresher, it's a quadratic is ax squared plus bx plus c. So that's why I said that sign on C. C is 25 here. If it's add, then that means if it's a plus sign, that means it's add. A times C, that will give me B. If it's got a minus here, that's subtract, then it's A times C that subtracts to give me B, right? Well, B tells me what signs we're working with. So B says it's positive, and since we're adding, both signs are the same, right? If B was negative, both signs would be negative. And so in this case, since B is positive and we're adding, they're both going to be positive here. So that's just a refresher on quadratics. Now that I notice these parentheses are just alike, what I can do is take that 7 sine theta plus 5 and square it. And now once I've squared it, I can take what's inside it and take that 7 sine theta plus that 5, and let's solve. So I got 7 sine theta, and I subtracted the 5 from both sides because I'm trying to get sine by itself. Actually, I want theta by itself, but it's attached to sine, so we got to go in that direction. And then we divide by the 7. So now I have this -5/7. Now let's take that sine theta and let's do the inverse to get theta by itself. And when I've done that, what do I notice? I type it in the calculator, make sure you're in degrees mode, and I get this number right here. And also just check on your homework on where they want you to round or not. So now I know what theta is. Theta is this, and now we're just going to determine the smaller and larger value. Well, on the unit circle, I'm going to take that 180 degrees, and let's subtract that -45.847 degrees. And when I do that, I get approximately 225.5847 degrees. Now I'm going to round to the nearest tenths. Okay. And then now what I want to do is, okay, so I got 360 degrees. That's the complete circle, right? And I'm going to add that -45.5847. which is going to give me 314.4153 degrees, round to the nearest tenths. And we have to be careful because, I mean, you don't want to go over 360 degrees, right? Because then you're actually outside of one whole circle, going into another circle. So now there's my 2 values here. Okay. So let's talk about number 5. Number 5 says find all real numbers in the interval of 0 to 2 pi that satisfy the following equations. We're in radians again. The first thing I notice is that cosine is even. So when I take that negative sign out, it just goes away. So now I got cosine of x plus cosine of x square root 3. And that means I got 2 of these cosines of x. equals square root of 3. And I want to divide by the 2 on both sides. So now I got cosine of x is equal to square root of 3 halves. And now let's find x by taking the inverse of cosine. Now I know what s is, right? Now that I know that, I just need to know what is cosine inverse of square root of 3 halves, and I find out that it's pi 6. So we're good. So what I need to do is pick the identity I'm going to use for the cosine, and what I notice based upon my s is greater than 0, then I'm going to use this identity. All right, that should be a pi. I get a little sloppy on my writing, apologies. There we go. All right, now let's plug in. So this value over here, we get x is equal to pi 6 plus 2k pi. This one here, I get x is equal to 2 pi minus that pi 6 plus 2k pi. All right, I'm going to add or subtract these two. I noticed that whenever you have a fraction, you have to have a common denominator. 2 pi is over 1. So the common denominator is 6. So I'm going to multiply top and bottom by 6. So now I have 12 pi minus pi all divided by 6. So let's finish it up. Now we have 11 pi 6 plus 2k pi. And now we can find some real values by plugging in 0 for k. When I plug in 0 for k, I get one value of pi 6. Plug in 0 for k here, I get one value of 11 pi 6. And let's play, well, those would be good enough, but you can plug in 1 for k, 2 for k, so on. Just depends on how many values they want on your assignment. All right, so let's move on to our next example. To find all real numbers in the interval of 0 to 2 pi that satisfy the following equation. So what I have here, I have a quadratic. Let's let y equals sine of x. And let's just rewrite it in a format that's easier to solve. All right, now that I've written it this way, let's go ahead and get 1 on the other side by adding it. Get it in a complete quadratic format. All right, I know it doesn't factor, so I'm going to use that formula where it says negative b plus or minus square root of b squared minus 4ac all divided by 2a. And let's plug in. Well, what do we know? We know a is 2, b is negative 3, c is 1. So let's plug in what we know. Negative 3 for b. 2 for a and 1 for c, all divided by 2 times 2. Now I got negative times negative is positive. Negative 3 squared is 9. Negative 4 times 2 times 1 is negative 8. All divided by 2 times 2 is 4. Now I got 3 plus or minus 9 minus 8 is 1 over 4. So I'm going to have 2 answers here, 2 possible answers. I got, let me get my pen working. I got 3 plus square root of 1 is 1 divided by 4, which gives me 4 divided by 4, which is 1. I also have, I'm going to say y is equal to 3 minus that 1 divided by 4, which gives me 2/4, which is 1/2. So now I know 2 possible answers for y. So what I can do next now is, okay, let's plug sine x back in for my y values. So let's do that. So I'm just going to say x is equal to, well, hang on a second. Before I get in too big of a hurry. I got sine of x is equal to 1, and I got sine of x is equal to a half. Let's find its inverse so I can get x by itself. Okay, now what is sine inverse of 1? It's pi halves. And sine inverse of a half is pi 6. And now I got my answers. And that's it.